Welcome students once again into the class of number theory, and in this video we will discuss one or two problems related to Chinese remainder theorem. In our previous video we have solved a problem, but that was not enough to understand the process of Chinese remainder theorem. So I am taking one more problem which I will solve by Chinese remainder theorem, and then I will take one problem that is a system of linear congruences but is not solvable by Chinese remainder theorem. So how to solve such problems we will see in this video. So let us see one problem that system of linear congruences x is congruent to 2 modulo 5, x is congruent to 3 modulo 7, x is congruent to 4 modulo 9. It is a system of congruences with m1, m2, m3. Here m1 is 5, m2 is 7 and m3 is 9. So m1, m2 and m3 are relatively prime in pairs. So this system of linear congruences can be solved using linear Chinese remainder theorem. So if we use Chinese remainder theorem, then what is a1 here? a1 is 2. This is your a1. Your a2 is 3, your a3 is 4, and what is your m1? It is 5, m2 is 7, and m3 is 9. So first of all, we will find m, that is the product of all these three, m1 into m2 into m3. So 5 into 7 into 9, it is 315. Now capital M1, capital M2 and capital M3. Capital M1 means m divided by small m1. So when you divide, you will get 63. Similarly, M2 is small m divided by M2. So dividing, you will get 45. And similarly, capital M3 will be 315 divided by 9, that is 35. And now consider the three new congruences, namely m1x congruent to 1 modulo m1, m2x congruent to 1 modulo m2, and m3x congruent to 1 modulo m3. So substitute the values. What is your m1 is 63, your m2 is 45, and your m3 is 35. Here your m1 is 5, your m2 is 7, and m3 is 9. Now reduce this equation as much as possible. That means you divide this 63 by 5, and what the remainder you are going to get is 3. So you can replace this 63 by 3. Again, this 45, divide this 45 by 7, and what the remainder you are going to get is 3. So this 45 can also be replaced by 3. Divide this 35 by 9, and what the remainder you are going to get this time is 8. So replace this 35 by 8. And now try to find solution of these linear congruences one by one by hit and trial method. Very easy. For the first one, you can check that the solution is 2. The value of x is equal to 2. 3 into 2 is 6, and 6 minus 1 is 5. 5 divides 5. So b1 is equal to 2 is solution of the first congruence. For the second congruence, what is the solution is 5. Because 3 into 5 is 15. 15 minus 1 is 14, and 7 divides 14. So the solution for the second one is, that is b2 is 5. And for the third one, what is the solution? Which value of x satisfies this congruence is 8, I think. 8 into 8 is 64, minus 1 63. So okay, 9 divides 63. So b3 is 8. And now what is your final solution? Your final solution, x is a1 into m1 into b1 plus a2 into m2 into b2 plus a3 into m3 into b3. what this value is coming out to be. A1 is 2, M1 63 and B1 2. So 2 into 63 is 126 and 126 into 2 is 252. So it is 252 plus. Now A2, M2, B2. So here is your A2 3 into 45 is 135. 135 into 5 and 135 into 5 is 675 I think. 675, let me check once again. Yes, I think it is okay. If there is any mistake in the calculation, I think you can correct it. Plus, now A3, M3, B3. So A3, 4 into M3, 35 into B3, 8. So 4 into 8 is 32 and 32 into 35. So this is 0, 7, 112 is 1120. And it is congruent to the number itself, modulo M. M means the product of all these three, that is 315. And what is the sum? Let us check the sum. That is 0, 5 and 2 is 7. Then 2 and 7, 9, 9 and 5, 14 is 4. 1 carry. 2, 8, 2. 10, 0. So 1 carry is 2. So 20147. But it is modulo 315. So it can be reduced to a number which is less than 315. How? Divide this number by 315 and replace this number by the remainder you obtain. So 2047, when you divide it by 315, the quotient is 6, 18, 90 and it is 7, 5 and 1. 157 modulo 315 is the solution of the system of linear congruence. Or you can also say that this system of linear congruences can be replaced by a linear congruence, by a single linear congruence, that is x is congruent to 157 modulo 315. So sometimes in examination you can find questions of the type replace this system of linear congruences by a single linear congruence. So what the single linear congruence is, this is this one. So this question can also be asked in this format. So this is a question, this is an application of Chinese remainder theorem. But as I said earlier that all the systems of linear congruences are not solvable by Chinese remainder theorem in case your M1, M2 and M3 and M4 and M5, whatever the number of linear congruences, if these small mi's are not relatively prime in pairs, then you cannot solve this system of linear congruences by Chinese remainder theorem. Then how to solve? So let us have another example, another question. Consider this system of linear congruences. X is congruent to 29 modulo 48. Let the second congruence be x is congruent to 11 modulo 50. Let the third one be x is congruent to 71 modulo 135. Here your M1 is 48, your M2 is 50, your M3 is 135. GCD of 48 and 50 is 2. It is not 1. So they are not relatively prime. Similarly, GCD of 50 and 135 is 5. It is once again not 1. So they are not relatively prime. So this system of linear congruences is an example of a system of linear congruences where mi's are not relatively prime. So it cannot be solved using Chinese remainder theorem. Then how to solve it? So we will solve it one by one. So you just start by taking the first congruence equation, and from here you can write this x as, or simply in first step I am telling you, in the subsequent steps I am not going to explain everything. So try to understand the first step here. It means 48 divides x minus 29. So that means x minus 29 is a multiple of 48. So let it be 48k. So x is 29 plus 48k. In the subsequent steps, whenever there is any congruence equation of this type, I'll directly write that x is this. So here also I'm going to write the solution of the first linear congruence as x is equal to 29 plus 48. Okay, it is the solution of the first one. And now replace this value of x. Put this value of x in the second linear congruence equation. So this will give, so you are substituting here 29 plus 48k is congruent to 11 mod 50. Simplify it, take this 29 to the other side. What you are going to get? You will get 48k is congruent to 11 minus 29. 11 minus 29 is minus 18 modulo 50. Now look at this 48, this 18, this 50. They are having a greatest common divisor, that is not 1. What is that? That is 2. So you can divide throughout this linear congruence equation by 2. Dividing 48 by 2, you will get here 24. Dividing this minus 18 by 2, you will get here minus 9. And here too, you will get modulo 25. Now, once again, this 25k, you can write it as 25k minus k is congruent to minus 9 modulo 25. Since this is a linear congruence equation modulo 25, so if in this equation you are having any multiple of 25, then you can delete that. You can omit that. And yes, it is there 25k. It is a multiple of 25, so it can be deleted. Now it is minus k is congruent to minus 9 modulo 25. So multiply both sides by minus 1, you will get k is congruent to 9 modulo 25. As I told you earlier that if this type of linear congruence is there, I will directly write the solution like this. So here once again we are having a linear congruence of this type. So what the solution you will get? You will get k is equal to 9 plus 25 L. This will be your value of k. Now once again, this value of k, you put there in the value of x because you are having here k. So substitute here the value of k. What the value of x you are going to get? You will get x is equal to 29 plus 48 times 9 plus 25L. And simplify it. Simplifying it, you will get x is equal to 29 and 48 times 9. 48 times 9 is 432 plus this is 461. So it is 461 plus multiply these two and keep it as it is 48 into 25L. I'm not going to solve this product because I don't need it. At the end you will understand why I'm not multiplying these two. So this is the value of x now, which is obtained from the first two. And now put this value of x in the third one. So what you are going to get from the third one, so this will give your x, that means 461 plus 48 into 25L is congruent to, this is x, is congruent to 71 modulo 135. And once again repeat the same process. So this, what is 461, you can take it to the right hand side. 71 minus 461, it will become minus 390, I think so. Yes, it is. Now once again look at this quantity is divisible by 15. This is also divisible by 15. This is also divisible by 15. So divide this linear congruence throughout by 15. So dividing by 15, what you are going to get from here, 16 into 5 is 80. So it is 80L. 80L is congruent to divide this by 15. You will get minus 26. So minus 26 and divide this by 15, you will get 9. So it is modulo 9. Once again, this 81L, you can write this 80L as 81L minus L. 81L minus L. And 81L is a multiple of 9. So it can be omitted, it can be deleted. And now once again multiply both sides by minus 1 to get L is congruent to 26 modulo 9. And this 26 can be replaced by a smaller quantity because you are having modulo 9. So divide this 26 by 9 and what the remainder you are going to get is 8. So replace this 26 by 8. And from here, once again you can write L is equal to 8 plus 9m. And put this value of L once again in the value of x. So what is your x? Your x is 461 plus 48 into 25 into L, and L is 8 plus 9m. So what the value of x you are going to get is x is equal to 461 plus this quantity. So 8 into 25, 200, and 200 multiplied by 48 is 9600, and plus 461. So add these, you will get 16010. So it is 10061 plus the second quantity. I am not going to multiply once again. It is 48 into 25 into 9m. From here you can write it in a single congruence as x is congruent to 10061 modulo 48 into 25 into 9. That's why I was not interested in solving this, because this I will use as a congruence, as a modulus. So this system of linear congruences can be replaced by a single linear congruence. X is congruent to 10061 modulo 48 into 25 into 9. That means this is a solution to this system of linear congruences. So this is how, where we are unable to solve a system of linear congruences by Chinese remainder theorem, we can solve the system of linear congruences by using this method. So here I am going to stop you. In the next video we will move on to Wilson's theorem, Fermat-Little theorem, and so on. Till then, thank you once again.